Hello, my name is Andres Quast, and today I will be discussing my Lab 4 for Physics 2211, Oscillations. So a quick introduction. Today we'll be using Newton's second law, which comes in a lot of forms, but we're looking at like F net is equal to dp over dt, or the change in momentum over change in time. Also be using the velocity update formula and the position update formulas, as you can see below. And the types of energy we'll be seeing with the experiment we will follow with are translational kinetic, which you can see in the following formula, and gravitational potential, which you can see in that formula, and the spring potential. The energy principle is one that states that the energy must be the sum of all of the things in the system, also in the surrounding. And in this one, our system is our surrounding has no energy, because we're making our system the spring, the weight, and the earth. And that should say surrounding down there, I apologize. But as you can see, we add up the change energy in the system is equal to the change energy in the weight, in the change of gravitational potential, and the change in spring potential. So some expectations and results that we'll be finding in our experiment. The expectation was to compare and find the predicted motion from the glow script code to the observed motion from the video using the tracker software, and to also view the changes in different energies using the glow script code. Our findings were that there was similar motion in predicted and observed, and this was because our system included everything, or because our system was including everything. The total change in energy was 0. Here is a quick screen capture of the tracker software. Our initial values of everything: the mass was 0.402 kilograms. The initial position was 0, negative 0.12, negative 0.69, and our initial velocity was 0, and the initial spring length was 0.1232. So some potential errors that could be found in this experiment were the neglection of other things in the surroundings, such as air resistance. Also, if the person who released the weight on the spring in the video accidentally added some of their force onto it, just that could change the reaction of the spring. So here are some initial conditions of the glow script code. We can see the gravitational force, the spring constant, the relaxed length of the spring, the ball position minus the spring position gives us L, and then we're able to use that to find L hat, and then S, and then you can see the different values for the energies that we're talking about before, that we kind of referenced all of that in the previous slides. And then here we go into the while loop that creates our images, and you can see that we have the first initial energy values. We have the calculations for the force. We're talking about the F net is equal to spring plus gravity. And then we have the position and velocity update formulas, and the updating the values of the spring force. And then at the bottom here, we have the different energies that we talked about before, factoring in all the change in energy, which is that delta K, delta UG, delta US, and delta E. And then we have the actual energy themselves, which is K, UG, US, and E. Here is the result of our graph, and this graph shows the different delta change in energies. You can see the oscillation period was, for the X value, was about 1.64 seconds. Whereas for the Y value, it was about 1.52 seconds. And you can notice that the orange line, which represents energy, stays at 0, which makes sense, right? Because our system included everything. All right. Hope you guys enjoyed. Thank you very much. Bye-bye.